What is signal-to-noise ratio in Neurotech data? Have you ever wondered how scientists make sense of the brain's electrical signals? One key factor in this process is something called signal-to-noise ratio. So, what exactly does this mean in the context of neurotechnology data? Let's break it down. Signal-to-noise ratio is a way to measure how strong a meaningful neural signal is compared to the background noise that can interfere with it. Think of it as a way to determine how clear a message is when you are trying to listen to someone in a crowded room. A higher signal-to-noise ratio means that the important signals are easier to identify amidst the distractions. In neurotechnology, the signal usually refers to the neural activity we want to study, like action potentials or local field potentials. These signals provide crucial information about how the brain functions. On the other hand, noise consists of any unwanted electrical activity or random fluctuations that can obscure these signals. This noise can come from various sources, including measurement artifacts or even external environmental factors. To calculate the signal-to-noise ratio, scientists compare the power of the neural signal to the power of the noise. For instance, when looking at spike recordings, the ratio might involve comparing the power of action potentials to the background activity during silent periods. This comparison helps researchers assess the quality of their neural recordings and how reliable the information is. Neurons communicate through electrical spikes, but these spikes can be influenced by many factors. Different areas of the brain respond to different types of stimuli, such as visual or auditory inputs. Therefore, the calculation of signal-to-noise ratio can vary based on the specific experimental context and the type of neural response being observed. In practical terms, having a high signal-to-noise ratio is essential for applications like brain-computer interfaces and neural prosthetics. These technologies relying on accurately detecting and interpreting neural signals. To improve the signal-to-noise ratio, researchers might enhance the signal strength, reduce noise through better electrode design, or use filtering techniques. Overall, signal-to-noise ratio is a fundamental metric in the field of neurotechnology. It guides researchers in evaluating data quality and the effectiveness of their neural recording systems. Understanding how well neural signals can be distinguished from noise is vital for advancing both research and clinical applications in neuroscience.